So I want to show you how to take the derivative of logarithmic functions, but before we do, I want to remind you of a couple things we've already learned. First off, if you have an exponential function, so you have some base to some variable power, and if you want to take the derivative of that with respect to the variable, then you get b to the x times the natural log of b. Now the chain rule says that if you need to take the derivative of a composition of functions, so let's say we want to take the derivative with respect to x of this composition, then you take the derivative of the outside evaluated at the inside times the derivative of the inside. If we use our exponential rule with the chain rule, then we can figure out what to do if we need to take the derivative of some base to a function. So this is just a case of the chain rule where our outside function is b to the x. So the derivative of our outside function is going to be b to the x ln b. The chain rule says you're supposed to take the derivative of the outside evaluated at the inside. If we plug g of x in here, we're going to get b to the g of x times the natural log of b. So if we assemble that all together, the derivative of b to the g of x would be the derivative of the outside evaluated at the inside times the derivative of the inside. So we have this rule, this generalized exponential rule, and that's going to be handy when we go to take the derivative of a logarithmic function. So let's say we know that y is the log base b of x. Now I don't know the derivative of this function, but I do know that there's another way of writing it. A log is just an exponent, and when we say y is the log base b of x, what we mean is that y is the exponent you put on b to get x. So in other words, y is the exponent you put on b to get x. That's another way of writing it. We go from having y as an explicit function of x to having y as an implicit function. So we could figure out what this derivative is by using implicit differentiation. Okay, now remember, we just saw that the derivative of b to some function is b to that function times the natural log of b times the derivative of the inside function. So what I'm going to do, if we look at this, we have y, which depends on x, right? Y is the log base b of x, so y is some function of x here. So if we go to take this derivative, we're going to get b to that function times the natural log of b times dy dx. On the right hand side, if you take the derivative of x with respect to x, you just get 1, and this allows us to find dy dx. It's going to be 1 over b to the y times the natural log of b. Now just one more thing, b to the y is x, so in this case we can actually write the derivative of y with respect to x explicitly as a function of x, because we can replace b to the y here with an x. Okay, so we now know that the derivative of y with respect to x is 1 over x ln b. That means that if you need to take the derivative of a log, then what you get is 1 over x times the natural log of the base. Let's see how that works if we put it with the chain rule. So we just saw this. The derivative of a log is 1 over the variable times the natural log of the base. Now a special case of this would be when the base is e, right? So that's what we call natural log. So in other words, this is log base e of x. Following that recipe, we get 1 over x times the natural log of e. But the natural log of e is the exponent you put on e to get e, which would be 1. So in the special case, if you need to take the derivative of the natural log, you're going to get 1 over x. Now let's see, what does that mean for the chain rule? So let's say we have a function of x inside this log. Well, the chain rule says you take the derivative of the outside evaluated at the inside. So since our outside function is log base b of x, then this would be the derivative of the outside. If we plug in the inside, which is g of x, we'd get 1 over g of x times the natural log of b. Then we'd have to multiply by the derivative of the outside. So I'm going to multiply by dg dx, or g prime of x. So what we get is the derivative of the inside over the inside times the natural log of b. Now, there's a special case. If the base happens to be e, remember ln stands for log base e, then we're going to get the same thing. We're going to get dg dx over g of x times the natural log of the base. But in this special case, if it's base e already, the natural log of e is 1. So we just get the derivative of the inside over the inside. Or if we were to write it in Newton notation, we'd have g prime over g. That's a rule worth memorizing there. When you need to take the derivative of the natural log of a function, you get the derivative of the inside over the inside. There's a more general case. If the base is an e, it throws in a natural log of b underneath there. Let's look at some examples. Here's one. We've got the derivative with respect to x of the natural log of x squared plus 2x minus 5. So we want to take the derivative. We take the derivative of the inside over the inside. The derivative of the inside is going to be 2x plus 2, and take that over the inside, and we've got the derivative. Here's another one. We want to take the derivative of the natural log of the secant of x. We take the derivative of the inside. The derivative of the secant is the secant tangent. So derivative of the inside over the inside. Notice that there's a secant multiplying the top and bottom, so the derivative of the natural log of the secant is the tangent.